Okay, so in this problem, we're told to calculate the weight of ethyl ether required to mix with 0.8 liters of water to make an aqueous solution, which has a freezing point of minus 1.5 degrees Celsius. Freezing point of water is 0 degrees Celsius, as you probably know, and our Kf value in this case is 1.86. I like this problem because it feels more realistic. It feels like this is a kind of problem you might run into if you were in a lab. So first we need to know our equation. Delta T is equal to Kf times your molality times the Van 't Hoff factor. In this case, the Van 't Hoff factor is not a real issue. It's just 1. Nothing dissociates, so we don't have to worry about it in this problem. And we'll find delta T. And recall, this is your basically the freezing point of pure solvent minus the freezing point of solution. So the freezing point of pure solvent minus the freezing point of your solution. Okay, so what does that mean? What that means is your pure, well, what's your pure solvent in this case? That's just your water. That's just this water here. So the freezing point of water is just 0. Solution, that's the whole mixture all together. That's what we're trying to get here. We're trying to figure out how can we make this solution. So we know that we want to get to minus 1.5 degrees C. That's what we want to get to. So we can plug it into delta T here. And that gives you positive 1.5. So that's our delta T. So, okay, we got that. And we also got Kf. They told us that Kf is just the 1.86 degrees C. So we can already set this up. So we got 1.5, 1.8, 86. And that's times the molality. The question is asking calculate the weight of ethyl ether required. So obviously we're going to have to use this molality to figure out the mass of ethyl ether somehow. Now you may recall that molality is equal to your moles of your solute over your kilograms of solvent. So we're going to use, somehow we're going to use this to find the mass. And we can totally do that. So when you set this problem up to find this M value first, because we're going to need that, we'll just set it up and 1.5 divided by 1.86, that's equal to M. That just gives us 0.806. Alright. So that's equivalent to this here, moles of solute over kilograms of solvent. So what's our solute? Well, again, the solute is what you put into your solvent. So in this case, it's ethyl ether. That's ethyl ether. What's a solvent? Solvent in this case is just water. Alright, so we need this guy in moles. I mean, this guy in kilograms. So that's what we're going to set up here. And we know what our molality is. So which of these can we plug in to find the other? Well, we're told 0.8 liters of water. That's the key here. We can actually find grams of water from that. The key thing here, and if you're not familiar with this, you have to know it. You have to know that something you have to keep in mind always when you're dealing with chemistry problems is that 1 milliliter of water is equal to 1 gram of water. And that's equivalent to 1 liter of water is equal to 1 kilogram of water. And that should make sense. But this is something you always have to remember. This is the one I always remember. 1 milliliter of water is equal to 1 kilogram or 1 gram of water, and then you can derive 1 liter is equal to 1 kilogram from that. So knowing that right there, we can find this value here. We find that by saying, okay, if we're given 0.8 liters of water and we want kilograms and want to get rid of these liters, well, as you can see from up here, every 1 kilogram is equal to 1 liter. So that's just 0.8 kilograms of water. Alright, so now we can take this value here and we can plug it in. We can plug this right in over here. So this actually turns out to be 0.8 kilograms of H2O. Oh, excuse me. This is on the bottom. There we go. And this moles here is what we're going to now calculate, because we already have our molality. So if we set this up different, if we just reset this up, this now becomes the problem here is your molality is equal to this value up here, which we'll just call X now, divided by 0.8 kilograms of H2O. So we now know we can actually calculate this molar value. This, how many moles is this? And by just doing this math here, you can find out that, you know, you multiply 0.8 times 0.806, and you'll find that X is just 0.645. And we now know that that's that value right here. Moles of C4H10O. Alright, so we now have a molar value. And again, the question's asking you to calculate the weight of ethyl ether required. Well, if you're given moles, you can easily find the mass, which is the same thing as weight. All you have to do is convert right to grams. We now need grams of C4H10O. And we want to get rid of these moles of C4H10O or ethyl ether. Now, for every 1 mole, you have a certain amount of grams, and that's just the mass of 4 carbons plus the mass of 10 hydrogens plus the mass of 1 oxygen. If you look at the periodic table, oxygen is 16, hydrogen is 1.01, carbon's 12. So 12 times 4 plus 1.01 times 10 plus 16 gives you 74.1. So all we're doing here is multiplying 0.645 times 74.1 divided by 1. And these units will cancel out now. And we will get 47.8 grams of C4H10O. That's your answer. That's the weight of ethyl ether required to mix with 0.8 liters of water, and you will make a solution that has a freezing point of minus 1.5 degrees Celsius.